Hello, my name is Ed Merriman, and this tutorial is about the TruePlanning at-risk integration solution. At-risk is a product by Palisade Software that allows users to perform Monte Carlo or other statistical analysis for the purposes of uncertainty or risk. It's an Excel plugin, and by integrating with TruePlanning, it allows users to perform uncertainty analysis on TruePlanning projects, particularly with inputs, which is something fairly new for us. As mentioned, at-risk is an Excel plugin, but it can be launched as if it was a regular program. So we'll go to the Start button, and then Palisade Decision Tools, and then Launch Risk. That's our at-risk 4.5. You'll see Excel launches. Currently we have a test license, so we get this dialog, click through, and you'll see the at-risk menu pops up. So we've launched at-risk, and it's brought itself up in Excel. And as I mentioned, our integration effort, because at-risk runs in Excel, we've chosen to produce an Excel solution that ties together at-risk and TruePlanning using the COM API from TruePlanning. So we're going to open that up. Again, this is an Excel file. We've opened up to the settings sheet. You don't have to touch anything on the settings sheet. This is really just for reference and for use by the macros. Go to sheet 1. You'll see this was the last project we used, but that can be deleted. It'll get filled in. We have a couple columns, and we also have our menu with Open Project and Select Input. So we're going to start by opening a project, and you're going to see I was prompted to choose a connection. This happens if you're given a file that has been used by somebody else whose connection name is different than yours, and it will supply a list of available connections. Most users will have one. Users who are in a situation where they have a corporate or centralized database but are also using the briefcasing approach, in which they have a local database, will have the ability to select between their local database and the centralized database. And they would just use a pull down and pick whichever connection they would want to use. The text you see here actually matches what you would see if you went into TruePlanning and went to Tools and looked at Connections. So in this case, I have one. If I had two, one might say local, one might say central, something like that. You'd see that. Okay. So going back to Excel, I'm going to click OK, and it's going to go out using COM, grab the list of projects that I own or are shared to me, and you're going to see we have two projects here. A quick note, you can't have a project open in two places at once. You can't have a project open in TruePlanning like I do here and open in at-risk at the same time, the at-risk solution. What I've done is create a copy. You can see here that I have, in this case, a copy of the project I want to target. And you can see that this one here actually has a little lock icon because it's the one that's currently open in TruePlanning. So when I go back to Excel, I'm just going to use the Paren 2 version. I've done this because I do want to be able to flip back and forth between Excel, the at-risk solution, and TruePlanning to show you different things. So what's happened here is we've gone out to the project, we've loaded it. Up in the top corner, we see the name of the project, the owner. We have a series of columns. We have the cost object name, which is basically the name you're going to see in the PDS. Compare against TruePlanning. You can see the UCAS, the unmanned aerial vehicle, air vehicle integration, airframe. Then the next column is cost object type. It just tells you what type of cost object the cost object is. And then you have a cost field, which is the estimated cost for that cost object. Input name, and you'll see here the way it's arranged, the cost objects get their top row in each section, gray, and then for each of the cost objects, a series of inputs can be selected. In this case, a fairly small number of inputs are selected. We basically have weight and structure for hardware components are the only inputs we've chosen to have selected right now. And so we have the weight of structure, weight of electronics, and we also have the value, and then the units. So that data has been pulled from TruePlanning into Excel using the COM layer. So as I mentioned, we have a fairly small subset of inputs. To change the set of inputs, we use the other menu item, the select inputs, and what you're going to see is a dialog that lists each catalog that's installed or available to the user, and for each of those cost objects within those catalogs, you're going to see a list of inputs. It is a subset. The list is a subset. Only inputs that are reflected by a single value, a single numerical value, are listed. At this time, we're not allowing users to use selection lists or inputs that are spread over time, such as system deployments. Those inputs require more than one number or require text, and they don't lend themselves at this point to this kind of analysis. If it's something that absolutely has to get done, if somebody needs to perform risk analysis on their schedule deployment in that way, or schedule dates, you might be, schedules at the activity level. We can talk about that in the future. Maybe that's an enhancement we have to make. But for now, inputs are limited to numerical inputs. So again, we see, for example, with activities, we might want to use functional complexity. Let's say we're not quite sure of the functional complexity of this model. We can come down, and we also, if we look back at the TruePlanning project, we see we have systems, assemblies, hardware components, purchase goods, and software components. So let's set some things. So we'll go down to hardware component. That's next alphabetically. So hardware component. We've already got weighted structure with electronic. That's good. And then let's go to purchase good. And let's do unit cost. And then software component, new code size. So we have new code size that's selected. And we'll go back and see that I didn't go down far enough. But at the bottom of the PBS in a list of the Excel, you'd see that we had new code size there. And then for system, let's say number of vendors. That'll give us a nice selection. I would argue that this is not necessarily the greatest effort in terms of a real risk analysis, but these values should give us something interesting to look at. So I'm going to click OK. We're being prompted now to ask if we'd like to reload the project. Basically, we've changed the inputs. Now we need to go back to TruePlanning and bring the project back in and list these inputs that we've now selected. So we're going to say yes. We're going to go back to TruePlanning, get the inputs back. What we should see here is when this fills in, those inputs that we've selected are now applied to the cost objects. So we said, for example, system, number of vendors. And when we say that, every system is going to get number of vendors. And every assembly will get functional complexity, hardware component, and then let's see here, for purchase good, unit cost. Oh, we have a fuel cell backup power system. We didn't set anything for that. That's fine. It doesn't matter if we don't have an input for a particular kind of cost object. And then we come down here. We have software components. We have new code size. So we've successfully pulled the data back from TruePlanning into Excel, and we've set ourselves up with the inputs we want. You'll notice when we do open the project, there's a checkbox on the bottom, use default distribution. What this does is it defines if on the loading of the project we are going to supply information that at-risk can use to perform distributions. So we'll talk about what that means. When we loaded the data, we brought in the PBS, everything like that, and in addition to that, when we brought in the input values, we created or we filled the cells for those input values with functions that are used by at-risk to perform the analysis. Really, at-risk has quite a fair number of functions. the majority of them are designed to define inputs or outputs. In this case, you see we have risk trying, which defines a distribution for inputs. And what that means is that at risk is going to take that formula and use the information in that formula to produce a series of numbers. We'll get to the details of exactly what risk trying does and some options in a little bit when we get back to the at-risk menu. The other cells that get an at-risk formula are the risk outputs. And what this defines is the things that at-risk, or the cells that at-risk are going to monitor to record results. So it's basically things change, inputs change, we shove them into TruePlanning, we turn the crank, we calculate, we get back costs. In this case, we're telling at-risk, look at those costs. So if you see a graph or an S-curve of how costs changed with these inputs, these are the costs that we're doing. And we do it for all of the estimated costs for all of the cost objects. If you're only, for example, we're interested in that cost, you could get rid of all of the other cost objects. And there's a few ins and outs to this. As I mentioned, if you set an input for a specific kind of cost object, every instance of that type of cost object has its inputs listed. You may only want to look at a subset. And what you could do, there are a couple ways to do that. One is pick the cells that you want to see, leave them alone. I'm sorry, pick the cells you don't want to have involved in the calculation, and you can basically clean out the cell. If you get rid of this formula, you will blind at risk to that cell, won't care about that cell, and it won't be part of the calculation. So, for example, I could turn off setting this input during our simulation. Another option would be I could just delete both of those rows. It works the same. If I didn't care at all about the fuselage or setting the values, I could delete all three rows. They could disappear. The simulation would run fine. What you can't do is delete fuselage and then set these values. What would happen is the way the VB works, it's going to try and find, as it finds inputs, it looks up to see what parent they belong to. In this case, it would try and find weighted structure for the assembly. Obviously, assemblies don't have weighted structure. That would be a problem. So if you want to use a variable or an input variable, you have to make sure its parent cost object, the owning cost object row is there. If you're not going to use any of it, feel free to delete all of it, or you could just go in and delete the contents of the cells, or even just remove the function part. You could leave the value, it just wouldn't change, or at least it would change, but we wouldn't, the at-risk wouldn't deal with it. So a couple options for manipulating the set of variables you're going to use. I started this by talking about this checkbox. So we know that with this box checked, the code is going to supply this risk trying function for each of the inputs. Oh, and the values it uses are, the middle value is the average, small value is the least likely, the big value is the most likely. What's done here is the current value for the input is used as a middle value, 50% of that value is used for the least likely, and 150% is used for the most likely. So in case 4,200, half of 4,200 is 21, 150% of 42 is 6,300. So that's how we come up with the math. That's how we get that value. But it's possible you don't want that to happen. So let's say you're going to use, you know what distributions you want to use. You don't want to use a triangular distribution. When you open the project, or when you bring the project in from TruePlanning, you have the option of turning this off, clicking OK. And what's going to happen here is the outputs will still be set as outputs. You'll still have those set to that risk output function. So at-risk will know to monitor these values, these costs on calculation. But the inputs no longer have that risk triangular distribution set. What they have, they're blank, and what this allows you to do is assign your own distributions. And we'll get to how you do that when we get to the at-risk menu. But I'm going to go back and reload this project with the default distributions, just because I don't want to have to go through and set them all. But once this reloads, we'll be good to go. I'm going to leave all of the inputs to be set. I'm going to leave all of the costs to be monitored as well. Okay, so we have our PBS. We've set our ranges. Another note, if it's 0 in this case, you get all zeros. Nothing happens here. Its ranges from 0 to 0. So in these cases, this weight electronics will not have an impact on the model. And there's a couple of other places where we have weighted electronics but no structure. Again, this won't have any impact. So if something's 0 and when you use the default, it basically zeroes out. It doesn't have any impact. So for example, this functional complexity. Again, now I could fix it here. I could go in manually and say, ooh, I really want this to range between 0, 0, and 1, maybe 0.5 and 1. But I'm going to leave that alone for a second. Okay? So we've set up our PBS, we've set up our inputs, we're happy with that. It's time to move on to actually start running the at-risk portion, because we've set everything up now. At-risk is ready to go. It knows that it has a spreadsheet with stuff that it can chew on. So we go to the at-risk menu. We'll go through these. File. As I said, this is an Excel file. This is savable. You can hand this around. You can keep it. You can do whatever you want with it. At-risk has the concept of a risk file as well. And what a risk file is it's something that contains the simulation settings and the results. And they're stored independently of the actual Excel file. It's possible to take a single Excel file, run multiple simulations, and save them off into different risk files so you could then look at it. You could say, here's risk run 1, risk run 2, risk run 3, and compare them, even though there was only one Excel file behind all of them. Or you could do the other way. You could have one risk file with a simulation setting that you like and apply it to multiple Excel files. So just remember that there is the concept of a risk file, and I would advocate you use it. We're going to talk about setting up the simulation in a second. There's a couple of things you want to have set to make this work, and it's convenient if you just have a file done. In this case, because I want to show you how to set something up from scratch, I'm not going to load one, but normally what I would do is come here, one of my pre-existing ones, I would open it, and I'm ready to run. It has all the simulation settings I need. We'll skip this for now, but just remember, I would advise you to do that. Define distribution. So this dialog is how at-risk wants you to construct the inputs or set up the distributions for the input values it will calculate when it runs its simulation. If you just pick an empty cell, it will give you risk normal from 0 to 1. However, if we look at, for example, this number of vendors and go back to define distribution, it will sense that you've picked a cell with an existing formula, and it will bring that formula up, and it will help you by showing you the graph. If you wanted to change this, for example, let's say I wanted my max really to be 5.5, I could change it. I've got 10, whatever. So this is the dialog you would use to construct your own custom distributions. If when you had opened this project, you had decided to not use the default triangular distributions, you would use this dialog to go and construct the distributions you wanted to use. For you at-risk jockeys, this will make perfect sense. But so this dialog really helps you determine or helps you set up and construct the formulas that at-risk needs to know what kind of distribution to apply to that particular cell. Add output. This basically allows you to construct a cell that looks something like this, where you've got a value, you've assigned a name to it, and you've told at-risk you want to monitor this cell. After it's set inputs for all the cells that have an input defined or input function defined for them, and turn the crank on Excel, and those values change, it's going to capture those changing values, and that's what it's going to build the curves on. It is possible to add either inputs or outputs to this model beyond what TruePlanning is doing. Obviously, you could, you could add some inputs and outputs because of the complex nature of working within the model. It would be my recommendation not to try and create your own rows for inputs, but use the existing infrastructure for that. But if for some reason there was another set of inputs you needed to calculate or another set of outputs you wanted to calculate, you could do it. A possible example, if you had two systems in the same TruePlanning model and you wanted to calculate, you wanted to graph the delta between them as the inputs are changing, you could theoretically come here and say something like equals, for example, we have this system here. Actually, let's see, how many systems do we have here? We've got a couple of systems, right? I think they're all kind of small. This isn't really good. This doesn't have a what-if structure, but let's just say we did this. We said this guy times 1.2. We were interested in this value. We were interested in tracking what happens to that system times some multiplier. And what we would do here is we have this value now linked as it changes, as the system cost changes, A17 will change. And we would just come up here to add output, and we could say it's test output. And now we've turned the cell on to at-risk. At-risk is going to look, it's going to monitor, it's going to create data for, result data for that cell. So you're not limited to the functions we've given you. You may have reason to want to do stuff. Again, it's up to you. For now, we're not going to do that. We're going to keep it clean. List inputs and outputs. This is basically just a helper dialog that lets you see where all the inputs and outputs are. In our case, it's pretty straightforward because they're all a nice, neat list. If you had a fairly complex spreadsheet with lots of things all over the place, that would be handy because you might have inputs and outputs hidden and distributed across a pretty wide area. This allows you, again, to find on the sheet your input and output functions. Fit distribution. I haven't played with this, so I'll have to research exactly what this does. I'm not a hardcore at-risk user here, so I've never played with this. Oops, cancel. We'll skip these two because these are very important, and we'll come back to them in detail. Report settings. This allows you to configure the reporting that at-risk will do. Advanced analysis, Windows. You guys, they're pretty straightforward. So those menus will basically get you set up and ready to run the simulation. Okay, you've got your data in the right place. You've produced any extra things you want to produce. PBS is set. You've got your inputs and outputs set. The next step is to set up the simulation. And again, as I mentioned, frequently you'll have a saved risk file with the simulation pre-configured, ready to go. But if you don't, we're going to show you how to configure a brand new risk. And the only thing you really have to do is check this box before each iteration's recalc. And then in here, recalc, make sure you get the R and the C capitalized. And that is a macro that ties into the TruePlanning COM and does all the magic for us. So check this box, add recalc, and you're good to go. A quick note, after this runs the first time, you will see a checkbox here and some information. There's a macro name in there. That's fine. You can save the risk file with that in there. If it's not there, it will just get re-added as it needs to. So that's it for this. The other couple, as you walk through this dialog, iterations you can pick. For the sake of the tutorial, we're going to do 10. I've been told that you really want to do at least 1,000 to really represent a good curve. And so, the math we see done here in this tutorial won't necessarily be the best math, but it'll show you how to work the knobs and things. But again, like I said, you should really do what I've heard at least 1,000 runs. From a sampling perspective, Hypercube seems to be the default, or you can do Monte Carlo. We'll do Monte Carlo because that seems to be what everybody wants. We talked about the macros, monitor. Here you can basically set how often it wakes up to say, hey, you want to quit. So we're going to say OK. And what we can do now, we go to File, save risk file. I'm going to call this t8.rsk.rsk. All right, so what I've done now is I've saved it. So if I want to open this file, this Excel file back up, I can. It should bring the risk tab with it because it knows that I'm using risk in here. And after I've opened it, I can go here and say open file and open my risk. Now it's warning me it's already opened. You want to revert? Yes. In this case, nothing happened because it was the same. But if I made changes to it, I could revert back to it. So quick look. You can see I've got what I need here. All right, so now we've set up the simulation. It's ready to go. We're ready to simulate. What we do, we click Start Simulation. We'll be prompted with this dialog. We click OK, and you'll notice in the bottom left, the simulation window. You may see Excel flash a bit. If you see some not responding messages, don't panic. There's quite a bit of work going on here. Lots of calculations. TruePlanning is in the background, screaming for mercy. So, we're going to let this run 10 times. You can see it's moving. What's happening here, again, is that based on those triangular distributions, those inputs are getting changed. We're sending data to TruePlanning. We're turning the crank, and we're getting results back that is being monitored and recorded by at-risk. Okay, so it finished. And what you can see here is this is the default screen. This is a results screen that TruePlanning will pop up after it has completed a run. And it's going to list outputs and inputs. And it tells you the cell name and the contents. A quick note, when the cells are filled with the at-risk variables by the process of pulling them in, when you have that checkbox checked, or just in case always for the cost objects, you're going to see that we give them a name. And what we basically, the name is of the convention. This is its number in the PVS, so 2, for example. We go back here, you'll see 1, 2, unmanned aerial vehicles. This is 2. Air vehicle integration would be, sorry, here, 3, so 3. And then you have double tilde, and then the name of the cost object, and then the name of the input. So when you go back to the results, it gives you a bit of a clue about which cost object. So when you see output, these are tied to the outputs. When you see the inputs, obviously these are tied to the inputs we set. So we can see here 2, unmanned vehicle, UAV system, number of vendors. So you can identify using those names that we provide what you're looking at. Obviously, inputs are great. You can see some of the averages, what the average values were, but it's the outputs that we really are interested in. As I noted before, hopefully, if not, I'll remind you, the first row is that system folder. So this always shows you the top level. It's possible to create a project with 2 or 3 or multiple systems or folders or assemblies directly below the system folder, so you won't necessarily get a combined total cost. Each system or each assembly would have its own cost, but wouldn't reflect its siblings' cost. So we always produce, when we pull in the project from TruePlanning, we always include the system folder so you can get a total for the project. If you're doing a what-if analysis, maybe that total doesn't make sense. If you really have two complete, visions of the same system, you don't care what the combined is because you really want to know what they're individually. But we give you that just to ensure we do get one top-level cost. So we go back to results. We go back to results. So now you can see, for example, this is the statistics. It gives us the minimum, the mean, the maximum, and some other things. So this is the first thing that defaults. There are many ways to view the result data in at-risk. As I said, I'm not a hardcore user. I'm sure there's a lot of things that I'm not showing you right now with this, but we can work on, getting you to what you need. The first thing everyone wants to see is the graphing. So like, for example, our ascending cumulative solid S-curve. And again, this is across the whole project. Again, 10 runs, so the math, the numbers are crap, but you get an idea. This is where you would go. If we run it 1,000 times, it would be a much prettier S-curve, and you would see it for the entire project. You can go after individual subsections. So, for example, I right-click on number line 10, which is the communications identity. Let's actually look for a system. So let's see here. So maybe we can go for air vehicle software. There we go. So where is air vehicles? There we go. So here is the system. We can get the ascending cumulative curve for the air vehicle software. And here you can see some bumps and things like that. So we have results. Additionally, you can see this quick report, which creates a whole new Excel workbook, but gives you a set of reports that are defined by at risk to be of value to people. So you can see here we have a series of graphs, correlated coefficients, distribution at the top level, and other things. So we get the 5% report here. You can see, we're 5% likely to hit 57, 151. We're 95% likely to hit 60 trillion. So the $3 trillion variation based on the inputs that we've set. And again, our inputs were pretty narrow with the triangular distribution, and we weren't setting a whole lot of information. So that's another way to view. I'm going to close this and not save it and go back to results. We can also see we can go to data. Data is for each run, and of course you get 1,000. You have 1,000 rows here, and this is showing you the outputs. And then eventually, if we scroll over far enough, we will get to the inputs in blue. So now you could, if somebody were to say, I don't believe your data, that's hogwash. You have this data. You could say, look, here's my run. Or if you get something like a really odd spike or dip, and you're curious as to why that happened, you can go back to the data and actually look at the inputs and recreate that model. It'd be kind of a pain because you have to type in all these inputs. You get a lot of inputs. It would take you a while, but it would be defendable. You would have access to exactly what created the situation to generate those numbers. I don't know if when people produce reports from at-risk, if they have to include this. Again, maybe some of our hardcore at-risk users can help me with this, but I don't know if you have to supply an at-risk file with all of the data for people, or if you just give them pretty graphs. But either way, you have it. You have all the information. Scenarios, sensitivities, So basically, we've run. So what I've shown you is that we have successfully used at-risk to produce a set of distributions, 4 inputs, set them in TruePlanning, turn the crank, calculate, get the results back, and run. A couple of notes, a couple of things to watch out for. It's a good idea to reload your project before each run. There are a couple of reasons for that. One, it means you're clean. 2, you really want to make sure the output functions are set. It's possible for these values. At-risk actually removes, and when it replaces those values, it removes the at-risk functions. So if you reload this project, you'll get those. You'll get back the those at-risk output functions set on those cost objects. Also, TruePlanning, the model is never saved. So what happens is, as these inputs are set, the calculation happens, we throw away the changes. We never save the changes. So the project should be in the same state at the end as it was in the start. So when you reload, it shouldn't be a problem. Also, it is possible for a input to be set to a value that's will create a model that won't run. Obviously, you could theoretically create a distribution that would produce inputs that are invalid. You want to avoid that. You'll get an error message when you're trying to set it. But additionally, it is possible with having all valid inputs to produce a model that won't run, whether it's a date issue or you get something out of range, or you put some, you spike something in some odd way and it just pushes it beyond some threshold. What's going to happen then is the calculations will continue, but your minimum values will come back 0. When the COM layer encounters a situation where a project can't run, all the results, all the estimated costs for the cost objects come back as 0. So what you'd see in that situation is your mins would all be 0. Whether that run then becomes a good run or not, I don't know. But if something, especially if you're doing 1,000 and it takes you a little while to do it, you're running it overnight, you don't want to come back in the morning and see, hey, this came out 0 for my min, so it kind of throws off your curves. So you got to be aware of that. Be very careful when you're picking your inputs. One of the dangers of just using this default piece, but the default is nice for testing and for playing. But I really think most people who are doing this seriously are going to want to go in, pick their inputs carefully, and pick their the ranges for their distributions very carefully, understanding how things are correlated with each other. I believe at-risk has a mechanism for sort of forcing inputs, or sorry, in this case, forcing the distributions to correlate to each other. I haven't played with that. People really start using this, and we need to become better advisors on how to use at-risk. Maybe we'll have to learn that. But like I say, there are ways. The example people give is the prime rate versus mortgages and things like that. As prime rate goes up, fewer people borrow money. As the prime rate goes down, more people borrow money. That kind of relationship, it's an inverse relationship or the same relationship, could be set. So again, you do have to be careful with the values you choose, but that is a run-through of the behavior of this. I hope you enjoy it. If you have any problems, you encounter anything, please contact Price. Let us know, Ed Merriman specifically, and hopefully we can figure out what the issue is, resolve it quickly. Or if there are features you want, if you want to not use cost but use hours, or if you want to use maybe an activity, you want to figure out development, manufacturing is your target across this run, not necessarily just cost. Those are things we can look at, to supply in the future. So any enhancements, bugs, issues like that, please contact us. I hope you enjoyed that. Thank you very much.